All right, some test-inspired warm-ups for you this morning. If you're watching at home, press pause right now, give them a try, and then come back and see how you did. I suppose you could just watch me do them, but it'd be better if you tried them. So number one, what it looked like many of you did was not do an algebra trick, and that's okay. You just jump straight in. Derivative of natural log is 1 over the argument times the derivative of the argument. And the derivative of e to the sine x is e to the sine x times cosine x. So that's sort of a 3-link chain rule problem if you do it that way. And then you can see that e to this, well, you could stop there. That is a safe stop. Like, you don't have to simplify. You could be done. But if that was a multiple choice test, multiple choice question, I'm guessing they would simplify to just cosine. The algebra trick is to recognize that you can take an exponent and move it in front of the log. So you could write this as sine of x times natural log of e. And what's the natural log of e? 1. So if y is sine x, then y prime is cosine x. So either way, if you do the algebra trick, I guess it's a little bit easier, but it's not that much simpler than just doing it kind of the long way. Either way, cosine x is the answer. Number 2, I hope, was an easy one. Derivative of natural log is 1 over the argument times the derivative of the argument, 4x plus 4. Let's see, so 4x plus 4 over 2x squared plus 4x. That's fine as a safe stop. What else could you do if you were looking for a multiple choice answer? You could simplify everybody by 2. So 2x plus 2 over x squared plus 2x. And that's as far as you could take it to simplify. Number 3, find the second derivative. Okay, so first derivative would be e to the x cubed times 3x squared. So first derivative, pretty straightforward. Second derivative, what's it going to take to do the second derivative? What rule am I going to need? Product rule. So f and g. F prime would be e to the x cubed times 3x squared. G prime would be 6x. And so the second derivative kind of gets confusing with e to the x when e is involved, because you keep taking the derivative of e to the x cubed, and it keeps being e to the x cubed times 3x squared. So you just got to be careful, put the pieces back together the right way. So let's go fg prime plus gf prime, and I'm going to save a little bit of time here. So the 3 times 3 is 9, x squared times x squared is x to the 4th, and then e to the x cubed. Perfectly acceptable answer. Multiple choice is going to force you into some algebra. Let's see, I could take out a 3. I could take out an x. And I could definitely take out e to the x cubed. Let's see what that leaves me with. On the first term, 2. Yeah, just a 2. It took away everything else. On the second term, 3 times 3 would get me to 9. X times x cubed would get me x to the 4th. And I took the e to the x cubed. So there's our cleaned up multiple choice answer. Worked the key last night just to make sure everything looked good. And it seems like the first time this year there aren't any mistakes on the test. Yay. Unless you find one tomorrow. But there's several questions that have a little extra algebra stuff at the end. And so this is where you get the partial credit, because you get some points for this, you get some points for this, and you get full points if you get there, even though it's a multiple choice test. Questions on that one? Let's do 4 together, and then I'll leave you alone to do 5 and 6, because we haven't seen one quite like 4. If f prime equals that ugly thing, and g of x equals f of x squared minus 5, find g prime of 3. What? So I need to find, let's start at the end. We're looking for g prime at 3. So I need to find g prime and plug in 3. Right? Like that's the goal here. There's a lot of mess to this problem, but my goal is to take a derivative of g and plug in 3. And then we'll go from there. Well, here's g. So g prime then, how do I handle f of x squared minus 5? What kind of rule is that going to be? Chain rule. So the derivative of f is f prime. Leave the inside alone. Right, one layer at a time. But what's the chain rule piece of this? 2x. Okay, now I need to plug in 3. And I will probably use f prime in a minute, but let's plug in 3. G prime of 3. Right, that means wherever there's an x, in goes a 3. So f prime of 3 squared minus 5 times 2 times 3. So f prime of 4 times 6. Now I understand why they gave me this weird expression for f prime, because now I need f prime. So I'll go use f prime. I have no idea what f is. It's probably something awful if this is f prime. But who cares? I just need f prime and plug in 4. So f prime of 4.
Why don't you make it f prime of 24? I thought I multiplied it.
Because it's f prime of whatever's in parentheses and then times 6.
So then we'll multiply by
Yeah, whatever we get for this, we'll multiply by 6. But the 6 is not in the parentheses, so I'm not doing f prime of 24. I'm doing f prime of 4. So let's see, that would be 1 times 6 divided by 3 is 2. So f prime of 4 is 2. 2 times 6 is 12. I'm pretty sure that's an old AP test question. That's the kind of stuff they ask. Where, again, when the teacher does it, it's like, oh, that's not too bad. But when you first see it, it's like, what in the world? There's a whole lot of stuff going on. All right, the next two are inverse type problems, which is what we did yesterday. So I'll press pause and give you a chance to do those. Again, I think setting up the table is the way to go. But I'll let you figure those two out, and then we'll go over those. So number 5, again, just a matter of keeping track with what they give you. F and G are inverses, so that's sort of my hint that I've got to use that reciprocal rule thing. F of 2 is 7, so that means x is 2 and y is 7 for f. The derivative at 2 is 3, and we know these guys are reciprocal, so something's equal to 1/3. Negative 3, I guess, would just be if you forgot the rule and you changed the sign rather than flip it over, so it's not negative 3. Let's see, I got to change the x and the y, so 7 and 2. So the derivative of g at 7 is 1/3. So not the derivative of f, we don't know anything about that. The derivative of g at the x value at 7 is 1/3. So b. And yeah, there's not really much work to show. Number 6, find the derivative of the inverse for the function of f at the specified value of x. So again, I'm trying to word it like the worksheet's worded. Let's set up the table again. F inverse. X is 1/2. That's given me for the inverse though. X, y prime. Again, I'm looking for this guy. I know it's reciprocals with that guy. But there's a lot more blanks to fill in here. So if 1/2 is the x value for the inverse, that means it's the y value for the original. So sine of x equals 1/2. That happens at pi over 6. So now I need to take the derivative, evaluated at pi over 6, and flip it over. So f prime is cosine of x at pi over 6. Well, I suppose I could be kind of lazy and just leave it as cosine pi over 6, and then the answer would be 1 over cosine pi over 6. And that would be accurate. That would be okay. That is a safe stop. If, however, this is a multiple choice question, cosine pi over 6 is root 3 over 2. And so the flip of that is 2 over root 3. So there's the answer we're looking for. So keep track of all the pieces for those inverse questions.